f of A. And this is
F of B.
if A is greater than B, is f of A greater than f of B?
Yeah. For this one, it is.
Yes, for this one.
I'm just asking you to tell me what you see. When A is greater than B, is f of A greater than f of B?
Yes.
That tells you you have an increasing function. So a function is increasing if for A greater than B, f of A is also greater than f of B.
So a quadratic is not increasing.
It depends on the boundary. It could be increasing within an interval. Understand? So a function is increasing within an interval if within that interval A is greater than B implies that f of A is greater than f of B, then you have an increasing function within that interval. But exponential function with A greater than 0, P greater than 1, P greater than 0 will be increasing for life. Am I making sense? No matter how small that greater than is. Okay? But if you look at when P is greater than 0 but A is in between, so P greater than 0 will be still this, but your A is a fraction. So let's see what happens if A is a fraction. P greater than 0, so I could have 3. Are you with me? Hello?
Yes.
A is a fraction, so let's say 2 over 3. What do you notice? It's decreasing. Can you see that?
It's decreasing.
You have a decreasing function. So that will be the conclusion for this one. So this is going to look like this. So here you will say, we will say the function is decreasing. Again, this is also big fraction, right? But let's change our, no, this is a fraction. Let's change our P to be negative. Of course, you know the effect of this negative. What is the effect of the negative I'm about to put?
It reflects.
It's going to flip it, right? So what kind of function are you looking at?
Increasing.
It's an increasing function.
Yeah.
So this function is increasing. Let's see what happens to this. When you have your P still negative, but your A is greater than 0. So we are talking about this one. What do you notice?
Decreasing.
Decreasing. So it's a flip of the original one. I better color code it before you get it mixed up. So this is also decreasing, yes? Why this gives us increasing? Hello, are you with me?
Yep.
Yes.
So this is, the function here is decreasing. So this is just summary of what's... Did I mix them up?
Yeah.
Which one?
Like, the third one.
This one?
Yeah.
This.
Oh, yeah.
Oh, sorry. Even these two.
Wait, this one
No.
is correct.
No.
This is correct.
Wait, this is decreasing.
Yeah.
This is inwards.
You mean this?
Yeah.
Oh, I see what you mean. So here, which one is the flip of this?
5.
This one.
Yeah.
So if you are talking about the flip of this, the flip will look like
This.
like this, right?
Yeah.
Okay. My bad. Then this one is okay? Yeah, because we can see that they are flipped. So I will use arrows. Can somebody tell me why this arrow is important? It extends
To the infinity.
to infinity, indefinitely. There's one important effect, one thing very important about exponential function, 2 raised to the power x. Provided p is greater than 0. You will notice it does not have a negative, okay, whether, you know, for all the types we have seen, it will either be a positive definite, if I may use that word, or negative definite. Is it that everything is positive or everything is negative? exponential function does not cross the x-axis. Do you notice that?
Yes.
It doesn't cross the x-axis. The moment it crosses the x-axis, what you are trying to tell us is that if it crosses the x-axis, what you are saying is that 2 raised to the power x is equal to 0 as what?
Has a result.
As what?
Has a result.
As a result. But does it have any solution?
No.
2 raised to the power x equals to 0 has no solution. What you are saying is that there is a power of 2, be it integer power or rational power, that will give you 0. Is that possible?
No.
So that is why you cannot have equals to 0. That is why it will never cross. That is why the y is equal to 0 is the asymptote. It's got to pretend like, okay, I'm coming home, it never reaches home. I'm coming home, it never reaches home. Tell the world I'm coming home, it still never reaches home. Understand? Yeah. So please take note of that. Thank you very much. So this is where we stop.
Unless k is negative.
Even if k is negative, dude.
Yeah.
Oh,
That-
I'm
it
talking
would-
about the
it wouldn't be-
exponential function without any additional stuff.
okay.
Oh, okay. I get what you mean now. What it's trying to say is when k is negative, it's going to drop it down, right? No, we are talking about the exponential function alone without any transformation being applied. All right? Okay, so let's have, I'll be giving this out after which, oh my God, it's 5:05.
Yep.
Oh no, you're late for PE.
It's okay.
Okay, I'll take a picture. Please go for your PE. I'll send the picture to you.
Thank you, Mr. Dan.
Yes, ma'am.
My homework.
See you tomorrow.
Oh my God.
2 each, 2 each, 2 each.
Suddenly we want tomorrow to come. 他没睡觉的时间。
Joy,
Joy.
is it still recording?
Can you stop?
Yeah, I have. Yeah.